Hello children, I am Shushmita and today interpreting with me is Hemalata. In previous part, we read about particle, matter and states of matter. Today, we shall read interchanges of state of matter. Before that, let's revise the last. Matter is made up of particles. The particles of matter are very small. Particles of matter have space between them. Particles of matter move continuously in liquids and gases. Matter exists in three states, that is, solid, liquid and gas. The force of attraction between the particles are maximum in solids, intermediate in liquids and minimum in gases. The particles are arranged orderly in the case of solids while particles move randomly in gases. Diffusion is possible only when particles of matter move continuously. Learning outcomes. At the end of this session, you will be able to understand about change of state of matter, effect of temperature, latent heat, effect of change of pressure, evaporation. Keywords: melting point, boiling point, sublimation, humidity, evaporation. Before starting the session, let's look at this concept map. You must have noticed that if we keep ice out in the kitchen, with time it gets converted into water, or when water is heating and you forget to turn the gas knob off, then it keeps boiling and a stage is reached when the vessel gets empty and no water is seen inside. This is due to the interconversion of states of matter. The phenomenon due to which matter changes from one state to another and then back to its original state on altering the conditions of temperature and pressure is called interconversion of states of matter. As we heat solids, the kinetic energy between the particles of solids increases, which decreases the force of attraction between them. They start vibrating and changing their positions. Slowly, due to heat, the particles become free and a solid convert into liquid. The conversion of solid to liquid is called melting, and the process of melting a solid into liquid is also called fusion. The temperature at which a solid melts to become a liquid at atmospheric pressure. For example, the melting point of ice is 273.16 Kelvin. Latent heat. The heat energy which is used to break the force of attraction between the particles of matter is known as latent heat. Since the heat is hidden, therefore it is called latent heat. Latent heat of fusion. The amount of heat energy required to change 1 kg of a solid into liquid at atmospheric pressure at its melting point is known as the latent heat of fusion. Just like in solids, the kinetic energy of particles of liquid increases. The force of attraction among them decreases and they start moving freely. As we keep on supplying the heat, a point comes when the particles overcome the forces of attraction completely. This is when a liquid starts changing into gas. Boiling point. The temperature at which a liquid starts boiling at the atmospheric pressure is known as its boiling point. For example, the boiling point of water is 373 Kelvin. Latent heat of vaporization. The amount of heat energy required to change 1 kg of a liquid into a gas at atmospheric pressure at its boiling point is known as latent heat of vaporization. Sublimation. Change of state of gas directly into solid and vice versa is known as sublimation. For example, camphor is a solid that directly evaporates into the air without changing to a liquid state. By applying pressure, we can bring the particles of matter close to each other, thereby increasing the force of attraction among the particles. When we compress and decrease the temperature of a gas, the gas changes into a liquid. Dry ice. Carbon dioxide in solid form is known as dry ice. It can directly turn into a gas by decreasing the pressure to 1 atmosphere. Evaporation. The phenomenon of change of a liquid into vapors at any given temperature below its boiling point is called evaporation. Let's explain the dependence of the phenomenon on these given factors. Surface area. More is the exposed surface area of any substance, more liquid droplets will change to vapor state. We have seen that clothes dry faster when they are spread on a line. The reason is that when we spread them, the surface area gets increased. Therefore, evaporation gets increased as more and more molecules are exposed. Temperature. An increase in temperature increases the kinetic energy of molecules. They break their force of attraction and hence escape or evaporate readily. For example, formation of water vapor on a cup of hot tea. It is because as the temperature rises, the particles start moving randomly. Therefore, the evaporation rate is increased. Therefore, when they escape, they also collide with the cup and get condensed. Humidity. More humidity, less evaporation. For example, clothes dry with difficulty on a humid day because as humidity is higher, that is more vapor in the atmosphere. Due to this, the escaping tendency of vapors decreases as the rate of evaporation decreases. Wind speed. With the increase in the speed of wind, evaporation increases. That is the reason why clothes dry faster if there is a windy day. As the speed of wind is high, the liquid particles take up the energy. As a result, their kinetic energy increases and they escape more readily and more easily. Points to remember. The states of matter are interconvertible. The state of matter can be changed by changing temperature or pressure. Sublimation is the change of the solid state directly to the gaseous state without going through the liquid state. Deposition is the change of a gaseous state directly to a solid state without going through the liquid state. Boiling is a bulk phenomenon. Particles from the bulk whole of the liquid change into a vapor state. Evaporation is a surface phenomenon. Particles from the surface gain enough energy to overcome the forces of attraction present in the liquid and change into the vapor state. The rate of evaporation depends upon the surface area exposed to the atmosphere, the temperature, the humidity, and the wind speed. Evaporation causes cooling. Latent heat of vaporization is the heat energy required to change 1 kg of a liquid to gas at atmospheric pressure at its boiling point.